Water Engineering. My name is Kyle Larson. I'm the project manager.
I'm Jensen Ricks. I'm the CAD engineer.
I'm McKenna Chen, the contact representative.
And I'm Christina Minchild, the water quality specialist. Our mission at Firewater Engineering is to prevent natural disasters from further damaging the communities that they affect, which is why we are working with the City of Fort Collins to develop a strategy to prevent the High Park fire burn area from affecting their water quality. In this presentation, we will go over background of the fire itself, as well as how it impacts water quality, the water quality parameters that we find most impacted by the burn area, an action plan on the treatment processes, as well as a project schedule and a budget. So, as you may remember from this summer, the High Park fire burned for almost an entire month in June. It started on June 9th from a lightning strike and consumed over 87,000 acres west of Fort Collins, Colorado. In that was the Cache la Poudre watershed, which feeds into the City of Fort Collins drinking water. Of the area that was burned, over 12,000 acres were burned at a level of high severity, which has the maximum implications into water quality, which McKenna will talk about.
So what happens after a high severity fire is the soil temperature increases to temperatures comparable to that of the fire. And this creates a temperature gradient, making VOCs condense. And when that happens, there is a surface layer of negatively charged particles, which makes the surface of the ground in the forest fire hydrophobic. As you can see in this picture, the water isn't percolating through the ground. So once that happens, surface runoff increases. During either peak flows or during a spring runoff event, the water will just run right off and go into the treatment facility. This is a picture that demonstrates the burn area response report taken in the fall. These green areas show a percent flood flow increase of less than 500%, and these red and orange areas are the areas of concern, which are the high severity areas which have 500% to up to 1,500% of increase of flood flow runoff. So our plan is to work with the City of Fort Collins to research the water quality impacts of a 10-year storm. We decided on a 10-year storm because a 2-year storm happens quite frequently, and a 10-year storm will have such high inflows of water and nutrients and organics to help prepare the City of Fort Collins for treatment. And that is why we will design a dynamic solution to account for that variability and create an efficient and cost-effective strategy.
So the City of Fort Collins gets its water supply from two places, Horsetooth Reservoir and the Cache la Poudre River. And then it's sent to their drinking water facility. And it's a pretty typical drinking water facility with coagulation, flocculation, filters, and then chlorination. And then it's sent out for distribution. The first area of concern is total organic carbon. There's two sources of this. In the short term, after the fire, we're going to have all of our vegetation is burned. And so that's going to have a lot of ash and smoke deposits. And so when it rains, those deposits are going to become dissolved in water, increasing the TOC by a significant amount. And for that reason, the City of Fort Collins turned off it didn't take water from the Cache la Poudre River for 107 days after the fire. And then in the long term, we get sediment deposition, more sediment deposition because increased runoffs. And then those sediments will leach dissolved total organic carbon into our water and increase in the long term. We care about this because TOC is known to be the precursor for disinfection byproducts, which can be carcinogenic. And the two main disinfection byproducts we care about are trihalomethanes and haloacetic acids. For our treatment solutions, we can do a couple of things. We can change the chemical coagulant and the dosage we're going to use, and we can do a mixture of a chemical coagulant and an organic polymer. So for TOC, for removal of TOC in a drinking water plant, we have percentage removals that we have to achieve. regulated by the EPA, depending on our source water and our alkalinity. As you can see, those percentages right here. And we also have our regulations for our disinfection byproducts. The THM is more of a concern because it reacts with chlorine, the chlorine residual left in the water, as it's being distributed to the area. So we have to monitor for THM at its furthest point in the distribution center.
Now, nitrates occur naturally in minerals and soil layers in the environment, and plants need them to live. But when there is a high severity fire, there is an excess concentration of nitrates where these plants cannot uptake enough nitrates, so the rest of the nitrates will either leach into the groundwater or flow into surface waters. And this can lead to nitrification and increase in algal blooms. And a human effect of nitrate is when babies are between 0 and 6 months old, they have a bacteria in their digestive system that converts nitrate to nitrite, which is highly toxic. And this will hinder their hemoglobin to transfer oxygen throughout the body, essentially suffocating them, leading to what is called the blue baby syndrome. The Safe Drinking Water Act regulates nitrate to 45 milligrams per liter. Nitrate is very difficult to treat for because it's very soluble and dissolves in water very easily. So that's why if we do find nitrate to be a problem, we will put in complete new systems, which include ion exchange, electrodialysis, and reverse osmosis. Now these systems do create a waste stream, which can increase the cost, but there are also benefits. For example, ion exchange can also be used in metals removal, which Christina will talk about.
Yes. So the source water for the Cache La Poudre watershed falls on a mountainous region, as you can see in this picture, that has a high mineral content as part of the Colorado Mineral Belt, as well as a long history of mining. The hydrophobic soil that Boone Kenna talked about increases the runoff, creating higher concentrations of surface metals in the water, but also drastically increases the levels of erosion, which, in bringing more minerals to the surface, allow for the addition of them to the water itself. Acid mine drainage, one of Colorado's biggest problems that I'm sure you all know about, lowers the pH of the water, and with more erosion and more runoff, you get potentially a dilution of it, but with the erosion and a drop in pH, you get more dissolved heavy metals. Once those heavy metals are in drinking water, you can have severe health effects ranging from brain damage to blood disorders to what the people talking about arsenic were looking at. It's not good. Although we looked at all the metals in the source rock and the burn area, these were the main metals of concern since they have the lowest levels as monitored by the Colorado Drinking Water Standards. And in treating for them, we are working in conjunction with the current monitoring system on the Cache La Poudre River to handle the high variances based on variability in flow from spring runoff to just storm events that are going to have the increase in flood flow. So as soon as the monitoring system will have an input of pH, TOC levels, and metal concentrations, we can then advise the treatment plant on addition of different salts or aeration methods that vary to precipitate those metals. And as a secondary treatment, the ion exchange that Boone Kenna talked about for nitrate would remove the remaining solubilized metals.
And going off of what Christina mentioned about increased surface runoff because of the hydrophobic soil, turbidity is our next topic of concern. The jar on the right represents a highly turbid water sample. Turbidity is a measure of the dirtiness of a water sample. It's most often tested using jar samples, and it's measured in NTUs, which stands for nephelometric turbidity units. It's important to keep in mind that that is not a concentration. It's more of just a level of dirtiness within the water, and that it's usually a visual indicator of how much total organic carbon is within a sample, in addition to what Buchanan and Christina talked about. We're worried about turbidity for two main reasons. The first is because of this increased water runoff due to the hydrophobic soil. That means there's a lot more sludge that's going to need to be removed at the water treatment plant. And if the turbidity and organic compounds are not removed, during disinfection, a lot of the microbes that we're trying to disinfect and kill will actually sorb onto some of the particles and avoid disinfection. That's why the EPA regulates it, that the turbidity should not be over 0.3 NTUs, and that's for 95% of their water samples. They recommend that you don't consume any water that has an NTU rating above 1, although it is a state regulated aspect of it, and in some rural areas they're capped at 5. The treatment for turbidity, it stays the same for what Jensen said about total organic carbon. We can increase the amount or type of coagulant used, especially if there's a high influx. And as shown in the diagram earlier, there's a pre-sedimentation bin on the way down from the Horsetooth River reservoir, and we might have to put in a few more pre-sedimentation bins to remove that, or just have to empty the solid sludge removal more often than we can currently do.
Another aspect we will look at are firefighting foams, which are used to suppress combustion and cool the fire.